Morning, everyone. My name is Enrique Muñoz, and I will present the work entitled Evolution of Suckler Cattle Farming Systems in the Spanish Central Pyrenees. I hope you all can see the presentation. You can see it?
Yes, we can.
Okay. This work has been accomplished by the Agri-Food Research and Technology Center of Aragon, thanks to the support of the GenTORE project. And it can be framed in the work package 1, Production System Metrics, assessing the system's context. Can you move to the following slide? Okay. Cattle farming systems have a major role providing and regulating crucial services in mountain regions. How mountain agroecosystem evolve is conditioned by and conditions human activities both at global, regional, and local scale. Adaptation at household and local level to socioeconomic changes such as agricultural policies, market changes, or increasing the opportunity cost of labor determine different trajectories of evolution of rural areas in general and cattle farming systems in particular. Understanding the diversity of current states and past trajectories can generate relevant knowledge to better contextualize and support optimal agriculture policy strategies for future changes. In this context, can we move to the following slide? In this context, the objective of this study was to document and analyze the main changes occurred in the cattle farming system in the Spanish Pyrenees from 1990 to 2018 by exploring the diversity of trajectories of evolution that have taken place. Said that, can we move to the following one? To carry out this study, we have a contact sample of 50 cattle farms that was surveyed in 1990, 2004, and 2018 in 3 different valleys of the Spanish Pyrenees. These valleys were Broto, Benasca, Valera, Barrabés, and we can see them on the map. It's in north part of Spain, the Pyrenees. The surveys gathered information about farm structure, such as herd size or utilities, agricultural area management, like the grazing season length or whether they fatten farm or not, and farmer profiles such as the farmer level of education or the family size. We also collect general information about demographic, economic activities, and livestock farm statistics from official regional statistics. Moving to the specific methodology, can we go to the next slide? We can say that we perform 2 different analyses, or here we will present 2, but we have a third one that it's under elaboration for a paper that we are elaborating. Okay, for the general evolution of the systems, we analyze a set of variables defining structure, management, economic performance of farms. Different differences were tested by ANOVA and Truskal-Wallis tests using a software for all statistical analysis. And after that, we select 9 variables for an in-depth analysis of trajectories of evolution. These variables were utilized agricultural area, herd size, livestock unit per work units, percentage of income from fattening per total income of the farm, grazing season length, variable cost per livestock unit, gross margin without subsidies per work units, stocking rate, and percentage of herd using mountain pastures. We use a methodology proposed by Dolevec and Chessel because it allows analyzing differences per farm, and their evolution once the general common trend of evolution time dependent is eliminated. Because we have data of 3 different time points, we needed to remove this time dependent common trend in order to compare these values in 3 different dates. Then a principal component analysis was performed on those variables to obtain the main factors that summarize the change occurred. And finally, a cluster analysis was carried out on those factors to establish a typology of farms according to the main trajectories of evolution found. Can we move to the results? Okay, here I will need you to click sometimes because I have some points marked in the slide. Well, as I said, we firstly analyzed the general evolution. We observed remarkable change in the study area, which occurred at different intensities in the two different time periods, the 1990 to 2004 and the 2004-2018. Can you click? Okay. And again, the orientation of farm production suffered drastic changes in both periods. The first period was characterized for a strong change from mixed production, mainly characterized for weaned cows and dairy farms, to the almost complete disappearance of dairy and the beginning of on-farm fattening. During the second period, on-farm fattening was strongly reduced, both in number and relevance for farms' income. And these orientation changes follow agricultural policy changes, both national, such as the introduction of milk quotas that discouraged milk production, and European, like the CAP upgrade in 1992, generating what they said called a capture of subsides behavior. Okay, you can click on. Okay. Parallel to this production orientation changes, we observe a trend to increase the utilized agricultural area during the first period, which didn't occur during the second one. However, herbicides increased significantly and labor input decreased significantly. You can click on also in the diapositive. Yeah. Okay, this trajectory has been described as a response to the increase in the labor opportunity cost in mountain areas due to the rise of rural and snow tourism. As a consequence, livestock units managed per farmer increased about 20, from about 20 in 1990 to more than 60 in 2018. And the last one, grafting season length increased about 1 month during the first area as a consequence of the changes in the orientation of production, and stabilized in the second one. Now we will move to the results in economic variables, the next slide. Okay. Total variable cost increased during the first period according to the increase of herd size. However, variable cost per livestock unit decreased. Feeding cost, which constitute a large share of variable cost, about a 40 and a 60% of it, followed a similar trend. Despite this increase in farm size, total output was stable during the whole period. However, the importance of subsidies increased significantly, allowing to maintain constant the total income. I forgot to advise you about clicking the slide. Okay, I'm already in the last one. The importance of subsidies increased significantly, allowing to maintain constant the total income and gross margin per livestock unit. This trend was similar to that observed in the French beef cattle farms in a similar period. Okay, we can move to the next one. Here I describe like the general trend in the three valleys in the three valleys together, but now we will see how different valleys have different trajectories of evolutions. Can we move to the, okay. We identified 4 clusters that define trajectories of evolution. Interestingly, we found that we have 4 trajectories. 3 of them were almost specific to each of the valleys studied, and 1 trajectory that was common of the 3 of them, revealing the high importance of local regional context in determining different paths. The first, okay, here we have the, I think it's too small. Well, the light blue one is the trajectory 1. This was mainly composed by farms from the first valley, Broto Valley, and it was named Broto trajectory, it was characterized by a small and stable utilized agricultural area, constant labor input, and the highest stocking rate due to a large increase in herd size during the studied period. I will be fast here because I think I don't have too much time. The second trajectory was mainly compounded by farms from Benasque, and it was characterized by labor extensification. Then the third trajectory was compounded only by farms from the third valley, from Maliera Valley, and this trajectory was characterized for having the highest land area and the lowest stocking rate of all trajectories. And the fourth trajectory that was compounded from farms from on the valleys was characterized by constant low values of most of the variables that we analyze, and also it has little changes during the whole study period. And we can move to the last slide. Okay, as final remarks, we can say that in the 1990s to the 2018 period, cattle farming system in the Central Pyrenees experienced a general trajectory of increasing herd size. But beside this common trajectory, farming systems in different valleys have followed distinct trajectories according to their trend towards extensification of labor, land use, and fattening orientation. In future studies, we aim to identify internal farm factors and external policy socioeconomic conditions, both at local, regional, and national level that drive to different trajectories of evolution observed. And here I have like a bonus track because we already did that final point. And what we can say is that we have some very important variables that are conditioning this trajectory at the local level, such as the farmer age, the family size, the farmer level of education, the percentage of population working in service sector, mainly in tourism, and the dynamics of the farm. I mean, the changes the farmer and their family are able to do in their farm in the next years. So this is all. Thank you very much, all of you, for your attention. And if you have any questions, we have some minutes later.
Thank you, Enrique. That was very interesting. Thanks for that.